the purpose of this lesson is to show you how to find inverse matrices with the intention of later being able to use them to solve linear systems using inverse matrices. First, let's look at some vocabulary. The identity matrix is a square matrix that has ones along the leading diagonal and zeros everywhere else. And we denote the identity matrix with the symbol I. And anytime we multiply the identity matrix times another matrix in any order, we always get that original matrix back. An example of a 2 by 2 identity matrix would be the matrix 1, 0, 0, 1. An inverse matrix, or matrices are inverses of each other when I multiply both matrices together in either order, and I can get the identity matrix. We'll know that a matrix has an inverse if the determinant of that matrix does not equal 0. And the notation for the inverse of the matrix is the capital letter that represents the matrix raised to the -1 power. So first we'll look at finding the inverse of a 2 by 2 matrix. So if we're given matrix A, whose elements are A, B, C, D, then what we're able to do is to transform that matrix a little bit by switching A and D so that we have D in the first position and A in the last position, and then negating or taking the opposite sign of B and C so that you'll see B becomes negative and so does C. We take this new transformed matrix and we multiply it by 1 over the determinant. Remember that this, which looks like absolute value of A, is really the determinant of A, which is calculated by multiplying A times D and subtracting C times B. So let's see how this would look in an example. So I'm given the matrix 1, 3, -1, 2. I want to find the inverse of this matrix and then verify that the two matrices I have are actually inverses of each other. So let's begin first by finding the inverse. So in order to find the inverse, if I label this as matrix A, first I need the determinant of A. The determinant of A is going to be found by multiplying 1 times 2 and then subtracting what I get when I multiply -1 times 3. And by some quick math, we can see that the determinant here is 5. Now to find A inverse, I need to multiply 1 over the determinant of A by this transform matrix where D and A switch places and B and C change signs. For the matrix that I'm given, A inverse would be 1/5. I'm going to switch the 1 and 2. So 1 and 2 are going to switch places. So the 2 becomes the first element and 1 becomes the last element. And then 3 and -1 are going to change to the opposite signs of what they were. So 3 is now -3 and -1 is now +1. And now I will multiply to find the inverse. This is multiplying by a scalar, so I'm literally taking the value 1/5 and multiplying it by every element in this matrix. So now that will give me 2/5, -3/5, 1/5, 1/5. So this is now my inverse matrix. If I want to verify that these matrices are inverses of each other, then I should be able to multiply A times A inverse and get the identity matrix. So that's what we're looking for. So A was 1, 3, -1, 2. And the inverse is 2/5, -3/5, 1/5, 1/5. And we're going to multiply this through our algorithm for multiplication, where we're multiplying rows by columns. And so for this very first one, we'll have 1 times 2/5 plus 3 times 1/5 And then we'll go from row 1 to column 2, where we'll then have 1 times negative 3/5 plus 3 times 1/5. Then we're going to go to row 2, column 1, multiplying there. I have negative 1 times 2/5 plus 2 times 1/5. And then I'll go row 2 times column 2, where I'll multiply negative 1 times negative 3/5 and add 2 times 1/5. And that will close out the matrix. And so to complete this multiplication, I'll have 2/5 plus 3/5, which is 1, negative 3/5 plus 3/5, which is 0, negative 2/5 plus 2/5, which is 0, and 3/5 plus 2/5, which is 1. And this is the identity matrix. So because I multiplied A times A inverse and was able to get I, then these matrices are really inverses of each other. Not because I notated it, but because the multiplication worked out. In the next slide, I'm going to show you how to use your calculator to find the inverse of a 3x3 matrix. To find the inverse of a 3x3 matrix, we will use our calculators. We discovered that the TI-36 Pro, as well as any of the graphing calculators, has matrix operations. I'll be using instructions from the TI-84, which will be the same instructions for the TI-36. If you have a different calculator, please see me individually so that I can help you find your matrix menus. Okay, everything that we do regarding matrices will access the matrix menu, which can be found by pressing second and the X inverse button. Whenever you want to enter values for a matrix into the calculator, you must use the edit submenu. And the first thing you will be asked for are the dimensions of the matrix. The matrix we're working with is a 3x3, so I'm pressing 3 and enter. And then you should begin to enter in the values that represent the elements of your matrix. And I've done that here with the calculator. Our next step is to tell the calculator to give me the inverse of this matrix, which is pretty straightforward. I'm going to go back to that matrix menu, second, X inverse. I'm going to remain on the name submenu and choose number 1 for matrix A, which is the matrix that I keyed in. Press enter. Excuse me, we need to quit first. Apologize. Then go to second matrix. Choose that first one and then hit X inverse, which will put the -1 at the top, and press enter. And this is our inverse matrix. If you want it to appear in fraction form, press math, enter, and enter once more. And you can see it written in fractions. It's a little bit neater. The second step was to make sure we verify that these two values were in fact inverses. So now if I go back to second matrix, choose matrix A, and multiply it times what I received as the inverse matrix, or I can just put the matrix A inverse, then I should get the identity matrix. And we can see that that is what happened here. So now you have an idea of how to find the inverse of a 2x2 matrix by hand, as well as a 3x3 matrix using the calculator. Watch this video as many times as necessary. We will practice with this in class, and then we'll begin to solve systems of equations.